Hello everyone, my name is Dr. T. Rajani. I am from the Department of Physics, VNR JYOTHI Institute of Engineering and Technology. Today I am going to deliver a lecture on solar cell. So we have seen the different types of semiconductors, p-type and n-type semiconductors, and when we combine the p-n n and n semiconductors, we are getting diodes. And we have seen how the p-n junction diode with a change in the construction material can work as a light emitting diode when connected in forward bias. In a similar fashion, today in this solar cell lecture, we will see how a p-n junction diode by changing the construction material, by changing the materials which we are using as a P and N type and connection part, we can make it to work as a solar cell. So solar cell is a device which converts the light energy to electrical energy. It is also it is also called as a photovoltaic effect or photovoltaic cell, and it is also basically p-n junction diode. It is also basically p-n junction diode, but it converts the light energy into electrical energy. So if you are looking at a p-n junction diode, we are not getting any kind of output from the basic p-n junction diode when connected in forward bias or reverse bias. But when we are looking at a light emitting diode, when connected in forward bias and taking compound semiconducting elements, the recombination of electrons and holes at the depletion region will give the light photons as a output. And in the case of solar cell, again you are considering some kind of semiconducting materials which are not a kind of a pure germanium or pure silicon, but a doped semiconductors when we are considering, and connected in reverse bias, they have the ability to convert the light energy. When light energy falls on them, it converts into electrical energy. So the symbol which we can say here it is, here the light energy is falling on the solar cell and converting into electrical energy. So this is the symbol of solar cell. So here you can see the normal p-n junction diode, there will not be any arrows, that is p-n junction diode. The LED you have arrow marks to the external because the light is emitting to the surroundings. So this is a photodiode or photovoltaic cell, or you can say conversion of light energy into electrical energy. Now coming to the construction, you can see here the construction, again a simple p-n junction diode only we are considering. It consists of two semiconductor layers p and n, and the metallic, but we are using a kind of a metallic electrodes to generate electric current in the pinnacle layer. So here one nickel plate anti-reflective coating is used. Here one anti-reflective coating is used on both sides of p and n, and we are using a metallic electrode, we are connecting them, and what happens is this reflective anti-reflective layer will be used to decrease the loss of light within the system. So here the middle layer is more important, where solar energy can be formed through the effect of photovoltaic effect. So based on the application, the amount of electrical energy that to be generated, the amount of electrical energy that to be converted, we can use different types of semiconducting materials. It all depends on the output end. We can use that kind of materials for this device fabrication. So here you can see when p-n junction diode is connected in the reverse biased condition, and you are connecting to a load resistor RL over here. So basically what happens when a p-n junction diode is connected in reverse bias, the minority charge carriers flows across the junction, the depletion region will be very high, and you are connecting a load resistor across the system, across the p-n junction. and the voltage which is generated over here along with the combination of resistance will start generating the current across the circuit. So when the solar radiation is incident on the cell, electron hole pairs are generated in the NNP region. The majority of them cannot recombine in the regions. They reach the depletion regions. So what happens is the depletion regions, the positive or the negative electrons from the N, negative electrons from the N, positive charges from the P starts accumulating across the junction, which is called as space charge distribution. This is also defined as a space charge distribution. This will generate a small voltage nearly 0.5 volts across the junction. For this voltage, when we connect a load resistor across the circuit, what happens is it results in the generation of the current. If the load is connected, then the current will flow. So the current, the light energy which is falling on the PN junction will be accumulating the charges across the junction, and some kind of minimum voltage is developed across the junction, nearly 0.5 volts range. And when we connect the load resistance, the current will be coming out of the cell and results in the electrical power generation. The generated power always depends on the kind of on the solar cell itself and how much load you have connected. 100 kilo ohms resistor or 100 ohms resistor, 2 kilo ohms resistor, 3 kilo ohms resistor. Depending on the load resistance, the generation of the electrical power takes place across the circuit. So these can be connected in series, and they can be used for different purposes. So VA characteristics similar to PN junction diode, we have learned the VA characteristics. Similar to LED, we have learned the VA characteristics. And coming to the solar cell, here also we are drawing a graph between the voltage on the x-axis and the current on the y-axis. So here when we draw the graph, we will get a curve like this. This is the curve which we are getting. So here what happens is at each and every point when we are multiplying the each I and V curve values, we are getting a power curve. The span of the IV characteristics ranges over here. Here this is called as a short circuit current. The current where it is having a maximum value at V is equal to 0. And it is called a open circuit voltage where the current is minimum and the voltage is maximum. So this is called as, we will define them as a short circuit current and open circuit voltage. And there must be a point where the solar cell generates the maximum power, and here this is defined as a maximum power point. For all the I and V values, power is generated, but this is a point where maximum power is generated that for that particular I and V values. Now coming to the, as I told you, this is not connected to any load. At that point of time, the current will be minimum or 0. Practically, we will look it as a 0 value, and the voltage will be maximum. And when the solar cell is short circuited, then the positive and negative ends are connected towards each other. The voltage across the cell is at its minimum, and the current flowing out of the cell reaches its maximum. So which is defined as a short circuit current and open circuit voltage values. So there is one particular combination, maximum power point, maximum electrical power is generated for a particular voltage or for a particular value of current and voltage. So it is a bend which we are saying, and they can be estimated from short circuit current and open circuit voltage. Both depend on temperature, because whenever the temperature or whenever the light energy falls on the solar cell, electrical energy is generated. The actual power output, whatever the maximum power output, it always changes with the temperature, ambient temperatures, whatever the generation you are happening, it all depends on the external temperature which is falling on the solar panel. So what are the parameters which we can calculate from this IV characteristics graph? First one is a short circuit current, ISC. So this expression for the total current in the solar cell is given over here. But when we put V is equal to 0, short circuit current will be nothing but equal to the photo current, IL, photo current, and open circuit voltage. Again, this is the maximum voltage developed across the cell when the current is minimum. So again, this is the main equation which we are using to connect that. When we put I is equal to 0, we will get as VOC by VT is equal to log of 1 plus IL by I naught. So this open circuit voltage with respect to VT, which is a thermal voltage, we are getting log of 1 plus IL by I naught. So the open circuit voltage can be equally calculated by using these terms: VT, thermal voltage, log of 1 plus IL by I naught. So this value can be estimated. Now maximum power can be determined by using the graph itself, at which it generates the maximum electrical power. This is shown over here with a circle. This happens for a particular combination of current and voltage. So for this combination of IM, and the VM, you can calculate the maximum power point. Next comes to the most important factor, fill factor. So what is this fill factor? Means maximum obtainable power, or what do you say, fill factor. Based on the fill factor only, we will determine whether that panel can be used for any device or for any application. Light collecting capacity, light absorbing power is measured in terms of fill factor. Light collecting capacity is measured in terms of fill factor. So it is the ratio of the maximum obtainable power to the product of short circuit current and open circuit voltage. This is the mathematical expression from which you can calculate the fill factor value. Usually this fill factor value is always expressed in terms of percentages. If the fill factor is 70%, then that is a very solar panel is very good. The light collecting capacity for the material is very high, so it can generate more electrical energy. In that way, we will conclude based on the fill factor values. So this light collecting capacity, again, directly it depends on the kind of materials which you are using to fabricate the solar cells or solar panels, or to fabricate the P and N type junction diodes. So fill factor gives the light absorbing capacity of the solar cell. It gives the quality of the solar cell. If the fill factor is 25%, for one another solar panel, if the fill factor is 50%, we will take the fill factor which is having very high value. Now, typically it is expressed in terms of percentages. At some points it can be expressed in terms of decimals also. And this fill factor is the main important parameter. To obtain this fill factor, we have to draw the VA characteristics and mention the short circuit current and open circuit voltage. These are all the parameters to define the fill factor. So solar cell is used to, solar panels are having large number of applications also. Solar panel works on the PN junction diode, and the PN junction diode, when connected in reverse bias, the space charge creations happens across the depletion region. So the further space charge creation which is happening, which is very less, but when we connect the load resistor, that can be generated as an electrical power or electrical current across the circuit. So if we look at the P and N type materials, the semiconducting materials, the P and N type materials can be joined and can be made to work as a diode, which is a passive element which we all use in every motherboard or in every device and in every circuits. So this PN junction diode can be connected in both forward bias and reverse bias, can be operated in both forward and reverse bias, and the construction or the working of the PN junction diode can be very well known from the VI characteristics of the diode. And if you take this PN junction diode as the basis to understand LED and solar cell, LED is again a PN junction diode which is connected in forward bias. Solar cell is also a PN junction diode which is connected in reverse bias. but the construction, the materials which we use to make or to fabricate the LED, to fabricate the semiconductor, to fabricate the solar cell are different. In the case of solar cells, we have to see that the light collecting capacity materials as a P and N type materials. In the case of LED, we have to see that more charges are accumulated across the junction within a less time and recombinations are taking place. So these are the basic differences which we should consider while fabricating the light emitting diodes or solar cells by using PN junction diodes or by using the P and N type materials. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.